The next thing we're going to be looking at is solving literal equations. In these equations, you're going to have several variables, and you'll be asked to isolate one in particular. So for example, if I have P is equal to 2L plus 2W, you could be asked to solve for W. That means that you're trying to isolate or get W all alone. So this is my W. Use the same rules that you were able to use when you solve regular equations. There just won't be as many calculations to do. So we know that this W is being multiplied by 2, and then they add 2L to it. So let's undo that. Let's subtract 2L from both sides of the equation. But on the left side here, those are not like terms. So we'll just write what we have. That's P minus 2L is equal to, those are gone, 2W. Now the last thing, 2 is being multiplied by W, so to undo that we will divide both sides by 2, which leaves us with W is equal to P minus 2L over 2. Next we have x plus 2y equals 5, and we want to solve for y. Again, here's our y. We want to isolate it or get it alone. So we follow our rules here. I can subtract x from both sides. It's just a number. Variables just represent numbers, so you're allowed to do this here. We're left with 2y is equal to 5 minus x. And then we'll divide both sides by 2, which gets us that y is equal to 5 minus x over 2. Next I have 1/5 xy is equal to z, and this time we're going to solve for x. So we're trying to get this x alone. Right when I see the fraction, I want to get rid of that, and so if I want 1/5 to go away, what we've seen before is that you can multiply by 5, or even 5 over 1, and if you do it on one side of the equation, you want to make sure you do it to the right side as well. Now this makes those go away. So we're just left with xy on the left, and on the right we have 5z. Now we're trying to solve for x, so I will divide by y. That leaves us with x is equal to 5z over y. Next we're looking at this literal equation. A is equal to 1/2 capital B plus lowercase b times h. And we want to solve for capital B. So we have parentheses, so that might make you think about distributing, but to me I see this 1/2 standing out, so I want to make that go away. Since this is all multiplication on this side, I can multiply by 2 over 1 on the right, and then do it on the left to maintain that balance. That makes that go away. So this looks a little bit nicer. At 2a is equal to big B plus little b times h. Again, we're trying to solve for big B, and if you see what's going on here, big B has little b added, and then it multiplies by h. So let's just undo that process. Let's divide by the h, which gets us 2a over h is equal to big B plus b, and then we'll subtract b from both sides, which gets us 2a over h minus b, those are gone, equals capital B. The next thing we're going to be looking at is 1 over x plus 1 over y equals 1 over z, and we want to solve for, let's say, y. Now if I want to solve for y, I see y is here in our denominator, and it looks kind of hard to try and deal with all these fractions. So it makes me think about trying to clear fractions. Remember, clearing fractions can be done if you multiply by the LCD. So when you look at the denominators here, we have x, y, and z, 3 different numbers. So our LCD can be found by just multiplying those together. That's kind of nice. And remember, to clear those fractions, you multiply both sides of your equation by that LCD. X, Y, Z. You can write it over 1 if you'd like. On the left, we'll end up distributing that because we have a sum. So I'll have xyz times 1 over x plus xyz times 1 over y is equal to xyz times 1 over z. What's going to happen here, because xyz is just a product of things, I can reduce. So x will reduce with x, leaving me just yz. Y reduces with y, leaving me just xz. Z reduces with z, which leaves me with xy. Now we need to look back. We're trying to solve for y, but I have a little dilemma here. There's a y there and a y here. Remember, we were solving for x, and there was an x on both sides. We were trying to get them on the same side together. So what I'm going to do is going to try and move this yz over to be with that xy. But they're not like terms. So I just write what I have. Xz is equal to xy minus yz. Now I can't solve this if I have the two y's there. I need to somehow try and combine them. Well, remember that if you have a y in one spot and a y in another spot, or same number in one and same thing in another, you can think of the distributive property. So what I mean is, if I think of undoing the distributive property, I could kind of pull a y out. That would leave me with x minus z inside. Right, so if I double check this, so y times x would be xy or yx. Y times z would be yz. Or zy, however you want to see that. So now I'm down to just one y, and y is being multiplied by x minus z, so I'm going to undo that by dividing by x minus z on both sides. So it looks like xz over x minus z would be equal to just y. Now I'll try this. I just want you to solve for t. We're looking at d equals r times t.